And I have like 3 jobs.
Yeah.
For the music one. I'm like, okay,
Yeah.
I'm just glad that they trust me enough to do that.
To take the quiz Friday?
Yeah.
Oh, yeah? There is a name under there. You get the cozy chair, but you gotta watch your knees.
Yeah.
Alrighty. So, this bell work is what the last chapter was that we had the test over on Friday, all that jazz. Solve the system however you choose. We have a grid up here, but you don't have to use it. How did you guys go about solving this system? Yeah. One option is realize, hey, I've got a y equals equation, which means I can do this with our substitution. Option 1 is use substitution. That would give us x plus 3 times y, but we know y actually equals our 2x minus 3 equals 12. So substituting the green piece into the y in place of the y. And then we can solve this using some distribution to get x plus 6x minus 9 equals 12. Combine our like terms, 7x minus 9 equals 12, and then what? Add 9. So we have 7x equals 21. So what does x equal? 3. Are we done? Like, that's my whole solution, right?
No.
No. What do I need to do to find my whole solution? Yep. I have a y equals equation. I can find out what y is using this guy. My y is going to equal 2 times my x, but now I know my x is 3 minus 3. So y is 6 minus 3. So what's y? 3. So my solution is the ordered pair 3, 3. I think that's probably the easiest way to go about solving this. You absolutely can do it with graphing. One of them is in slope-intercept form. The other one,
I did it graphing and I did not get that answer.
you did get the answer?
I didn't get that.
Did not. All right. Let's see.
I probably did it wrong. Knowing me, I didn't. I definitely know I'm iffy on.
Yeah, that one's where we got, because if we would put the slope-intercept form, it would be minus 1/3 of slope with a intercept of 4. So 4 down 1 over 3. So what it is, so if it looks like you try to do x, y intercepts, our x intercept would have been 12 and our y intercept would have been 4. So I'm not sure where we got our points from.
My brain.
I was like, I'm not really sure that you know where those threes came from either.
My brain is lagging. It's fine.
That's okay. It's 7:15 on a Monday morning. What's up? Yeah. Not correct. Just clarifying. Okay, questions on this? Your tests are graded, and in Canvas and Skyward, they were not bad, for the most part. Not saying there weren't some that were a challenge, but for the most part, they weren't bad. So we'll have a little bit of time at the end. If you want to see it, you can. I'll rip the folder out, but they weren't awful. But we are going to be moving on to our next chapter because, you know, that's how things go. Next chapter. We're going to have a lot of graphing in this next one, but we're not going to need any rulers. Not until like the second to the last one. Because we're not going to be talking about lines or linear functions. We are going to be living in the world of quadratics.
Ew. Do we have things for this, or do we have to use our notebooks?
Notebooks, and I will give you the pictures. Yeah, I only really bring these back into this, like, super duper. This is not. So, like in our probability statistics, I printed that out. That was almost entirely word problems.
Yeah.
And having the table being accurate is super important. But this is never consistent. Wherever it is. If your grades stay the same, you magically change. Like after like class and stuff. Then you're being consistent. Okay. Then we need to change something.
I'm just consistently failing.
Miss B,
What's that?
do you follow Pike Flyers on Instagram?
I believe it is added, but the question is whether or not I open Instagram. So,
Because I was just about to ask if you saw the group picture we
No.
took on Saturday.
I technically have Instagram. Technically.
Technically.
I think the only times I ever like post on Instagram or really open Instagram is one, if the TikTok live streams are super glitchy, or two, if there's a contest.
So.
What's up?
Yeah, this is you just on Instagram?
Yeah. As I have one. It probably has pictures of the Taylor Swift bulletin board.
We have a Taylor Swift bulletin board.
It says in my doing homework era.
Oh yeah. Like I said, my brain is glitching today.
I was like, it is like I am ready. Abigail.
Were you the? Yeah, I noticed. Were you the one who convinced them to do that?
Oh, I made that. From scratch. I cut out every one of those B's. Okay, Miss B. And I hot glued them on the string. The amount of friendship bracelets me and my youngest have in the popcorn bucket from the movie release is honestly problematic. It's the sheer number of friendship bracelets we have for a concert for which we have no tickets. We're 100% planning to go and hang out in the parking lot. What's up? And like one of her friends is having a birthday party for the concert with no tickets. They're going in to have a hotel room with no tickets. But they're gonna stand outside and just not listen and be in the ambiance. But so we have made the picture I took of her with the bracelets. It goes from fingertip to shoulder on her. She's 10. She's 10.
Oh my god. Her brain.
Alright, so what we're doing is we're going to be dealing with quadratics this whole chapter. And honestly, for the rest of the year, we're going to be working with quadratics a lot. And so we're going to start with kind of doing almost as a guess and check style, but it's honestly the most efficient way to go about graphing quadratics. And we're going to get through that. Like, I was not kidding.
Oh my god. Is your daughter's hair purple?
I'm just on the tips.
I did that before. I like
That was the very first time we did lightener in her hair, and I wasn't willing to take it all the way up.
My hairdresser still has to bleach my hair if I get my hair done, even though I want it.
It's all about the tone of it.
Yeah.
And her hair is will be as dark as mine when she finishes growing up because my hair was 100% identical to that at that age.
Mine was like basically black and blonde.
The luck of some people. All right, so quadratic functions, what that means and where the word quadratic comes from in there is the squared part. So quadratic functions are always going to have an x squared term. Always, every single time. That's where that comes from. Don't ask me why it's quad instead of for a power of 2. It's because of geometry being a fun thing and Latin roots being what they are. But quadratics have an x squared. And what we're really going to be focusing on a lot today is this thing called our axis of symmetry. We've talked about symmetry before in shapes. Like back in Unit 1, when we were talking about our end behavior, we found point symmetry versus line symmetry. Quadratic functions are always going to have line symmetry. And in fact, that value is going to be super important for us because this axis of symmetry, this equation right here, it's on your picture, but it's also this guy right here. The axis of symmetry actually gives us the x value of the vertex. Our axis of symmetry always goes through the vertex. The vertex being the HK point. So our axis of symmetry is always going to be in the center of a table when we're trying to graph. And when we're looking to fill in a table to plot some points for our axis of symmetry, we are going to take these values of B and A from our equation here. Now this equation has no parentheses, and it either is set equal to y or it is set equal to 0. Only options. It says y equals or f of x equals, or it says 0 equals. If there is a number there, we are not in standard form. So it has to be a 0 or a y. So this chunk needs to be 0 or y, or f of x, or h of x, or whatever of x it is. Has to be in order for us to be able to use this tool. But our axis of symmetry gives us the x value of our vertex, which then we can use to find the y value of our vertex by plugging things in. We're also going to take advantage of the fact that we know x squareds have line symmetry, meaning things will be reflected equally across. If I know this point, I know that point. If I know my y-intercept, which is the constant that's on the end over here, I'm going to make that not be green. So my y-intercept, which is always, always, always this constant right here, just like our mx plus b, well, it's not b, but it is c this time. That's my y-intercept. So if I know my y-intercept, I know where my axis of symmetry is, I can find this point over here. They're going to be the same distance. Those two pieces are going to have the same length. So we're going to use that to help us make these graphs, even though we know very, very little about quadratics right now. But that's how we're going to start with graphing. Is we're going to start by finding our axis of symmetry, finding our y-intercept, and kind of filling in points in between. So our first one we're going to graph is this. We've got f of x equals x squared plus 2x minus 3. And what we're going to do is we are going to use a table to graph. So we're going to wind up making an XY table like this. But what we need to figure out is we need to figure out where to start. And what we would love to do to get that good view of the middle, just like we used to do for absolute values, is I need to make sure that my vertex is in the middle. To figure out where my vertex is in the middle, I'm going to find that axis of symmetry. So our axis of symmetry, which I will often write as AOS because I will spell symmetry wrong. That's when we use our x equals the opposite of b over 2a. So looking at this equation, we would need the opposite of b. What is the value of our b?
2x.
Just the number.
2.
2. In our axis of symmetry, we're never going to have a letter. So it's never going to ever say 2x. It's just going to have the 2, which is our b. As our standard form, we have ax squared plus bx plus c. So what's our a? 2 times. What number is in front of our x squared? Say it louder and with confidence. 1. Everyone see where I found those values? So if the x value of my vertex is negative 2 over 2 times 1, what is the x value of my vertex? What does this simplify down to?
1.
Negative 1. Because this is negative 2 over 2. So the x value on my vertex is negative 1.
So the x-intercept is negative.
So the x value of my vertex. So this is giving us our vertex point. Where it this guy down here. We're finding our vertex right now. So we use this guy to find the x value of my vertex. To find the y value, I've got a whole equation up here that tells me y equals whatever this hot mess is. So we're going to take our x value that we found, my negative 1 squared, plus 2 times my x value, which is negative 1, minus 3. And we can type that in the calculator. Make sure you put parentheses in there. But you can type that in a calculator. Negative 1 quantity squared plus 2 times negative 1 minus 3.
Negative.
Should spit out a value of negative 4. So we're going to have our vertex at the point negative 1, negative 4, which is over here. And we know our axis of symmetry is at that negative 1, so everything that we find is going to reflect over this line. This is our axis of symmetry. You don't have to draw the axis of symmetry in, but I'm going to just show you where it is. So everything will fold over that line. We have line symmetry across that place. The way that axis of symmetry helps us is as I go out from my vertex, I need some points to the left and some points to the right. It'll help us fill in some values. So looking at our table here, if I want 2 points to the left of negative 1, what values could we use? Negative 3 and negative 2. If I want to go to the right of negative 1, what should we use? 0 and 1, right? Well, if x is 0, that's my y-intercept. What's my y-intercept going to be on this? Say it louder. Not negative 1. Not negative 5. Where did we get negative 3 from? Because it's our constant. Think of it like that plus b on our line equations. This guy is our y-intercept. So when x is, that's a p. When x is 0, y is negative 3. And since I know everything is going to be symmetrical over that dotted line, I also know that this guy is going to be negative 3. One step away. So as long as you set up your steps as one away, I know these are going to match. So we really only have to calculate one more value. I need to do either f of negative 3 or f of 1 to find my values. Either way, I do recommend a positive if you have the choice. What's up, Darren? Yeah, give me a second, marriage pass. So if we want to find f of 1, substitute in 1 in place of the x's. 1 squared plus 2 times 1 minus 3. What are we going to get?
0.
0. We'll go back here. Go back. We're taking advantage of the symmetry in order to save us some work. You can absolutely just pick those values, substitute them all in, and go from there. It'll 100% work. I'm just trying to save you guys some work by doing it this way, using the fact that there's symmetry here. So what do we get for the value of f of 1? What is 1 squared plus 2 times 1 minus 3? 0. So we know that this point is 0, and because of our symmetry, I know its matching partner on the other side will also be 0. So we have 5 points here that we can graph up. We have negative 3, 0, negative 2, negative 3, negative 1, negative 4, 0, negative 3, and 1, 0. We're going to connect them up. We do not use rulers on this, so it should be U-shaped. That was bad. We still want to go as far as we can on our graph, but it's going to be significantly more wonky. There is your first quadratic. We're just taking advantage of the fact that we know these points are going to be symmetrical to each other across this axis of symmetry. That's why we only had to actually calculate 2 values instead of having to calculate all 5 of these by substituting them in, because that would take us a very long time. Questions on that part right now? All right, so then my next question is, what is our domain? We'll talk that in a minute. Which x values work? Or how far left, how far right? No. How far left does it go? Negative infinity. It doesn't stop going left. It's going up real fast, but it's still going to the left. And so what's the biggest it can be? Positive infinity. So our domain goes from negative infinity to positive infinity. I could use all real numbers. Whatever number I wanted to do. Totally fine. What is our range?
Oh, I was thinking about range.
You were thinking range.
Negative 1.
Perfection. Our lowest is that negative 4. The very bottom that it can be. And the highest is positive infinity.
And I do a square bracket.
We do a square bracket because it's a point I can touch. And that's a part of it. questions on this one. We're going to do another one, but I want to practice like that. Okay. So here's our next one that we're going to do. We got our f of x is negative 1/2 x squared minus 2x plus 3. Ew, fractions. I know. Luckily, we get calculators, so that helps a lot. We're gonna fill in a table so that we can plot up these points. We pick x's to find y's. And the first thing we need to do is we need to figure out where our axis of symmetry is so that we can figure out where our vertex is. So step 1 is to find that axis of symmetry. Our axis of symmetry formula, that's that x equals the opposite of b over 2 times a. So what is the b value for this equation? So the b value itself is negative 2. So we need the opposite of negative 2. So I'm just going to write it exactly like that for our filling in part here. 2 times a. What's our a?
1.
Careful.
Oh, wait, it's 1.
Okay, no.
It's squared. I don't know.
You were super close.
No, go ahead.
Negative 1.
Negative 1/2. Don't lose the signs.
That's what I forgot.
Oh, I had it.
Okay. And you can type that into the calculator right there. You can even do the fraction inside a fraction part. Like, it'll do that.
Mm-hmm.
You could also do it in pieces, which is honestly a little bit easier. Because the opposite of negative 2, that's positive 2. 2 times negative 1/2. What is 2 times negative 1/2?
1.
Negative 1/2.
Oh,
Negative 1. So we have 2 over negative 1. So what is the x value of our vertex?
Negative 2.
Negative 2. So that means in the middle of our table, we put our negative 2. That's what that tells us. I do not want to have that pen. That means this guy goes in the middle. That's how we get that point. To find our y value of there, we're going to take it and substitute it into our whole equation. So I'm going to take that negative 2. I'm going to do it at the bottom of my graph here just so I don't run out of space. My f of negative 2, substituting in our negative 2 into the equation. We're going to have our negative 1/2 times negative 2 squared minus 2 times negative 2 plus 3. So there's a lot of negative signs in here. So using the calculator, so you can type it in, just make sure you include all of those parentheses. Negative 1/2 times negative 2 squared minus 2 times negative 2 plus 3. What do we get for the y value of our vertex?
5.
Mm-hmm. So I know we're going to have a vertex at the point 2, 5. Sorry, negative 2, 5. So up here is where my vertex is going to be. Unfortunately, we can't get the graph from just that. So we're going to pick 2 points bigger, 2 points smaller than our vertex. So if I need smaller than negative 2, we're going to count by ones. So we're going to have negative 3 and negative 4. If I need bigger than negative 2,
Negative 1.
negative 1 and 0. Hey, we like it when 0 shows up in our x's because without any work, what is the y value when x is 0?
3.
3. It's our c value, this guy down here at the end. So I know this guy's 3. Which means what other point has a y value of 3? The -4 does. The one that matches on the other side. So I really only have to figure out one more point in my function. We don't have to do a whole lot of.
I got 4.5. Is that
You got right.
okay?
Yeah, so we're going to substitute in either our -3 or our -1. We should get the same value either way. So we'll take our -1/2 times our -1 squared minus 2 times -1 plus 3. Type the whole kit and caboodle into the calculator. And we should wind up with 4.5. You get that by doing f of -1 or f of -3, either way. Because since this is a quadratic, since it has this axis of symmetry, this guy will have the same exact value. So when we're plotting it up, our -3, 4.5, we're going to estimate it's kind of about halfway between here and here. For my -3, 4.5, and my -1, 4.5. Then we have our 0, 3, and our -4, 3. And from there, we can really start to see the shape of this thing. So we're going to connect them up, doing as best as we can to make it not be super wonky. Should be something like that-ish. So, what is our domain? Yeah. Again, we can go all the way left and all the way right. I can go all the way from -infinity to +infinity. How about our range? -infinity to 5. The very top it can be. Good. Excellent remembering. -infinity, the very lowest it can be, to +5, the very highest.
With a square bracket.
With a square bracket, because I can poke 5 and have it be a thing on my line. Okay, so we're finding this vertex being that turning point, that maximum or our minimum. Thinking back to those extrema from Unit 1. Oh snap, they're all tied together. What? Which will help us with our very last question of the day. We have one more question.
Oh, yay. Ew. Disgusting.
I mean, it's a catapult. Launching a pumpkin.
At least it's a catapult.
It's a catapult. Launching a pumpkin. And then I wear my pumpkin dress. We're launching pumpkins.
There's no C.
There is no C. But we're also not trying to graph it. We're trying to figure out when the pumpkin is going to be the highest. So what point am I looking for? If I want to know when it is the highest. The what? The absolute maximum. We're in a quadratic though, so what is that called? The vertex. The highest upon this will go on a quadratic. Our maximum is always going to be at our vertex. So when we're looking for the highest, or if it if it was a different one and we're looking at the lowest, that would also be our vertex. So anytime we're looking for the highest or the lowest, we're looking for our vertex. So, what tool do we use to find our vertex?
The opposite over 2A.
Yes, our axis of symmetry tells us where our vertex is. So we're going to use that axis of symmetry formula, AOS, where x equals the opposite of b over 2 times a. So, what is our b?
-1.
The b is positive 160, but we put into the fraction minus 160. Because our b is positive 160. That's our b right there. Over 2 times our a. What's our a? Negative 16. So what is negative 160 divided by 2 times negative 16?
5.
Just letting other people think it. When in doubt, type it in the calculator, guys. We should get 5. So when will the pumpkin be the highest? At 5. Did they ask us how high it would go?
No.
No. Could we find that?
Yeah.
How would we find that?
By putting
Put 5 in place of the x. So x is our time. So at 5, probably seconds, just from what we know about catapults and pumpkins and gravity. So we're going to call that seconds. That is a pretty decent pumpkin flight. And we could find out how high it goes. They didn't ask us to do that, but we could. All we cared about was when. It hits the highest at 5 seconds. What is our y-intercept on this one?
Real.
We
0.
don't have one, so it's 0.
Okay.
Okay.
Keep it 0.
So, start of a new chapter. There we go. So we're also going to use this tomorrow. So some of these have things like vertex form in them, which you might remember how to do from not last chapter, but module like unit 1, when we were doing absolute values and like all our polynomial things. So we're also going to talk about it tomorrow. So you guys do 1, 2, 4, 6, 7, 8. So pretty much the only ones you can't do right now are 5 and 3. So you could do all the others. Okay, so we're going to have about 30 seconds till the announcement bell rings. But if you want to see your quiz, your test, while they're doing announcements, I can get those out. You don't have to come see it, but if you want to see it, you can.
You gotta go there.
Yeah, because I have to keep them.